This is lesson 5.2, solving quadratics by completing the square. And in this lesson, we are going to learn another way to solve quadratics. So far, we have worked with factoring, and so let's review some things that we know about that. So pause the video and complete these 3 questions at the top, and then we'll relate that to what we're doing today. Okay, here's what you should have for these 3 questions. So when you have a quantity squared, where you have a binomial in parentheses and then you're raising it to the second power, remember that you need to write it out. You cannot do something like just saying on this first one that you're going to have x squared plus 9. Then you're missing part of it. So remember that you have to write it out, and there's that middle term. Now if you look at all 3 of these problems, notice patterns, because when you notice patterns, that helps you move forward in math. And so we look at what the patterns are. So we notice that for all of these first terms, okay, we've got x squared on all of them. And of course, if it was a different letter, we'd have like m squared or a squared or whatever. So that part is similar, just different letters. But what we do is we're taking this number and we're squaring it. And so people noticed that before because that's what they want to do anyway. Also notice on the last number that is this number squared, this last term in the binomial. And again, that's something that people notice really easily because they want to do that anyway. The problem is they only want to do those 2 things, and so that's where the problem comes in. The thing that's different here, and I want you to really notice this middle term. And so look at what the middle term is. So if we look at 6, how does that relate to what I see in my binomial? If this middle term is 8, how does that relate to what I see in my binomial? If this one is negative 10, how does that relate to what I see in my binomial? And so if you notice the pattern here, if you have x plus a quantity squared, you're going to take the x squared and you're going to take the a squared. To get the middle term, you're going to take this number and you're going to multiply it by 2, and then you're going to multiply it by that. So that's what we have. We have 3 times 2 and then times x. That's what is in that middle term. Here we have 4 times 2 and then times x. Here we have negative 5 times 2 times x. And so that's something that always happens. And so if you have a plus there, everything's positive. If you have a minus, then you're going to have x squared, and of course this is going to be plus a squared over here. The difference will be is you're going to have minus 2ax. And so looking at what the patterns are, that's going to help us for what we're doing today, which is called completing the square. So let's go to the next part of this. The pattern that we've noticed gives us a special type of product. So a product is an answer to a multiplication problem, and this special product has a name, and it's called a perfect square binomial. So remember that a binomial is 2 terms. Oh, sorry, not binomial, because it's 2 terms. It's a trinomial, perfect square trinomial. Binomials are what you're multiplying to get that, but then when you get done, you have a trinomial. So when we do what's called completing the square, we're manipulating an equation so it becomes a perfect square. And we have to follow rules. So rules like things like we can't just go around adding something because that would unbalance an equation or something like that. And so when we have, if we had a picture, if I had something like this and it was made up of squares and I had to complete my square, I would be, adding something in there to complete that. But I can't just go around adding to equations or expressions because then that changes the value. So when I say we must follow the rules, that's going to help us maintain the truth or the equality of what we have. So when we've learned how to solve quadratics before, we've used factoring. So things like, you have x squared plus 2x plus 1 equals 0, and so you factor that. And then you say, well, the zero product property means that either x plus 1 has to equal 0 or x plus 1 has to equal 0, so x has to equal negative 1 both ways. And that's really great, and factoring is wonderful. The problem is it doesn't always work. Okay, so that's the problem. And so if you have one method and it works some of the times wonderfully, but it doesn't work the rest of the time, it's not as useful as we would like. So one thing that's great about what we're going to learn today is completing the square always works. Sometimes it's not pretty, but it always works. And so it's really awesome quality. Okay, we're going to go look at this first example. So the example x squared minus 4x plus 2. And so if we go to factor it, think about how you would try to factor it. So I would try to do x there, and then for 2, the only thing I could do is 2 and 1, and there is no way in the world I'm going to be able to get those together to make a negative 4. There's no way. Nothing that I could do at all. And so this becomes not factorable, but that does not mean that there's not a solution. It just means that I can't find it the way that I'm used to finding it. So we are going to do something else. So we're going to manipulate this equation. And so by manipulate, I mean I'm going to turn it into a form that I can do something with it, but I can't change the value of it. So this is called completing the square. So what we're going to do is we're going to take this equation, and the first thing that we're going to do is we're going to take the first two terms, the x squared and the x, and I'm going to kind of separate those, and so I'm going to put the plus 2 over here. Just kind of spread it out. And then what I'm going to do is I'm going to take this part of it and I'm going to complete it so that it's a perfect square trinomial. So looking back at the previous pages where we did these are perfect square trinomials. And so if you look at, I've got the x squared and then the 2 times a, and then I've got that number squared right there. So how can I use that right here? This number right there would be 2 times 2. And so if if this is what you're multiplying it by anyway, and this is your a, like I had in the other one, I'm going to take 2 squared, and that's 4. So if I add on 4, then what I have now is I have a perfect square trinomial, and I can factor it. And so you might be thinking, okay, so what does that mean? Well, let's take a look at what I'm going to do with that. Now, if I went around just adding my 4, that unbalances my equation. And so this is no longer equal to 0. It's equal to 0 plus 4, because if I add 4 to one side, I have to add it to the other side. So one way you can do this is add 4 to both sides. Another possibility, and so sometimes I'll do this, is where if you add 4 to the left-hand side, I can just take it away from the left-hand side as well. I'm going to do that this time just because it's interesting to look at, and then we'll go back and look at it the other way. So what I'm going to do is I'm going to take this perfect square trinomial right there, and I'm going to factor it. So because it's a perfect square trinomial, it's going to factor to be a perfect square. This term right here is going to be half of that one, or the square root of that one, because that's how it was created. And then what I have outside my perfect square is I've still got my negative 4 plus 2. So that's what I have. And so now if I try to solve that for x, I know some things about how to do that. If I'm trying to solve for x, I'm first going to get that 2 to the other side. And then I need to get the square root out of there. So because this entire thing is squared, I can solve that by taking the square root of that. It's like the square root of x squared. I can just take the square root and it's just x. This is just going to be x minus 2. So I have to take the square root of the other side as well. Now remember that when you take the square root of both sides, you have to do a plus or minus right there. You can't just say it's square root of 2. So it's plus or minus the square root of 2. And then to solve that for x, I'm going to add 2 to both sides. And those are your solutions. And I say those because there's one solution and then there's another solution. And those are my solutions. I could never have gotten those by factoring. But if you take this and plug it back in for x, it's going to work in your equation. And so you can try that. Get your calculator. And if you will type in 2 plus square root 2 in your calculator, and then you're going to hit the button that says STO. So that means we're going to store it. And you're going to store it in x. So your x variable button. And then when you hit enter, it'll give you the decimal approximation for 2 plus square root of 2. And then what you're going to do is now in a new line on your calculator, you're going to type in x squared, so the variable x squared button, minus 4x plus 2, and you hit equals, and it equals 0. And so you know that that works. It's a solution. You can go back and do that again. You can do 2 minus square root of 2 and then store it in x and do the same thing and make sure that that works too. But that's how I know that those are both solutions. So when I come up with these solutions to my quadratic, I'm going to write them in set notation. So I'm going to write x such that x equals, and you can just write it all at once, 2 plus or minus the square root of 2. We do that a lot with quadratics. One thing about quadratics, is they're always going to have two solutions. This number right there tells us how many solutions are in any polynomial equation. And so that's going to tell us that there's always two solutions. So you're not going to come up with just one solution. And so we'll talk about different cases. All right, let's go ahead and try some other problems. We're going to talk about some steps first for how you do completing the square. So I showed you. Let's go through the actual steps. Okay, your leading coefficient, that's the number in front of the x squared. It needs to be 1. So if it's not already 1, you're going to have to make it be 1. So we'll see some examples where you have to do that. You're either going to move your constant over to make space like I did, where I moved the 2, I scooted it over, right over there. So you can do that, or you could just move it to the other side. So I could have just subtracted 2 and put the negative 2 over there in the first place. Maybe, well, I'll show you another one like that. Okay, now the next part, this is where it gets a little bit tricky and you have to pay attention. You're going to take your b, which is this number right there, and you're going to take half of it. So we did 4 divided by 2 is 2, because remember I said 2 times 2 is 4, and then you're going to square that. And that's what you're going to add to both sides, or you can add it and then take it away. So that's what I did here. First I said you could add 4 right there, but then I said, but let's just take it away from this side. So what you're doing is you're making it so like nothing ever happened. And then you're going to factor this perfect square trinomial that you created. You created it to be this way, and so it should always factor that way. And so the thing with the plus or the minus sign in the middle, it's going to depend on what sign you see right there. This last one will always be a plus. It's what comes right in front of the x that matters. And then you're going to solve the equation. So let's go ahead and practice some problems. I'm going to do a couple with you, maybe the first 3, and then you can try some and just come back and see if you're doing it right. So number 1, this is very similar to the one that we just did. I noticed that my coefficient is 1. My leading coefficient is 1. Now if it's not 1, we would have to make a change. And so if you look on your practice problems on your notes, there is one problem on there that does not have a leading coefficient of 1. So we'll talk about what to do there. So it is that. So I'm going to either scoot my negative 17 over, so I could do it like this, but keep it on the same side, or I could do it like this, where I have the equals and then add 17 to both sides like that. It doesn't matter. It's kind of more a matter of personal preference. And so then what I'm going to do is I'm going to take half of 16, so 16 divided by 2 is 8, and then I'm going to square that. So I'm going to add 64. And I'll just do it on this other side too, so I can show you both how that works. Now, I can't just go around adding 64, so I can either take away 64, or I could add 64 to the other side. Either way, it doesn't matter, just whichever one you like. And so what I have, you don't want to say, okay, that's 0 then, because then that undoes everything you just did. So what we're looking at is we're looking at now, this is my perfect square trinomial. And so I'm going to factor that. So the way it factors is it's going to factor as b plus this number. The square root of whatever that was, that's what goes right there. And so it'd be the same thing either way you're doing this. And then right here I have negative 64 and negative 17. So I would have minus, and then that would be 81 equals 0. Over on the right, I'm going to have equals positive 81. So you can see that the only difference is the 81's already on the other side with the one version of this. So I'm going to add 81 to both sides right here. And so I don't need to do that on the other side. So I'm going to have b plus 8 quantity squared equals 81. And now I'm going to take the square root of both sides. So whichever way I'm doing that. And then what I'm going to have is I'm going to have my b plus 8 equals plus or minus. You have to get the positive and the negative because you put the square root in this equation. You're solving that. And so then 9. Okay, now here's where people kind of get this messed up. They want to write b equals, so it's negative 8 plus or minus 9. Here's the thing. That's two problems, negative 8 plus 9 and negative 8 minus 9. You cannot leave it like that because you know what that is. Negative 8 plus 9 is 1, and negative 8 minus 9 is negative 17. So when you go to write your solutions, you need to write those solutions and not negative 8 plus or minus 9, because that sounds like you don't know what you're talking about. Okay, let's try another example. Number 2, we're going to separate that. So we're going to have r squared plus 8r. I'm going to go ahead and put my negative 9. I'm going to move it to the other side. So I'm going to just say equals 9. And then I'm going to complete my square. So completing the square means what are you going to add right there So if this is your A and this is your B and this is your C, what are you going to make C so that that's a perfect square? So you take half of 8, so 8 divided by 2 is 4, and square it, so 16. And so then I would add the same thing to the other side. So I keep my equation balanced. Okay, now I have a perfect square trinomial because I created that. So I'm going to have R. This is a plus sign, so it's going to be plus, and then square root of 16 is 4, or half of 8 is 4, however you want to look at that. And then on the other side, I have 9 plus 16 is 25. And so I'm going to take the square root of both sides. So R plus 4 equals plus or minus 5. R is equal to negative 4 plus or minus 5. That's negative 4 plus 5, negative 4 minus 5. So that's positive 1 and negative 9. So I'm going to say R such that R is equal to positive 1 and negative 9. It doesn't matter what order you write those in. It's not an ordered pair, so you could write negative 9 and then positive 1. Usually I do the one that comes with the plus first because that's usually how we say it. All right, we're going to do number 3. Now this one's going to be a little bit harder because of this leading coefficient. So let me take you through this one, and then I'll have you go to the second video and you can just try some on your own and see how it's going. So number 3, because of this leading coefficient being 3, that's the first thing I need to worry about. So there's a couple of ways we can do this. One way is we could divide everything by 3. Sometimes that works out really nicely. Like in this problem, everything here is divisible by 3, so that works out really nicely. So if you did that, as long as you're dividing every single thing on both sides, you can do that. So this is what I would have. And then I can take it from there and do just what I did on the previous problem. So that's not that hard to do if it works. The problem is that sometimes that doesn't work. Sometimes, like maybe you'll have a number here that doesn't divide by 3, or this one doesn't divide by 3, and so then that creates this other problem. And so just knowing what's going to come up later on, let's talk about another option that we have as well. So another option that we could do is I can take a look at these first 2 terms, because they're what I'm concerned about with creating the complete square anyway, and I could factor out a 3. So I could factor out a 3, and that would leave me with b squared plus 4b. And then because I need to make this perfect square trinomial, I'm going to leave some space. I'm not going to factor 3 out of the negative 72. So I can either leave the minus 72 like that, or I can just go ahead and add it to the other side and just be done with that part of it. So I'm just going to go ahead and add it to the other side. So I'm going to have 72 minus 9. Now, initially, this probably looks a little bit more confusing doing it this way, but you're going to have a lot of times where this is going to be how you need to do it, and so I want to make sure that you know what to do here. So what you're going to do is you're going to look inside this, and that's where your perfect square is going to be. So you're going to take half of 4, which is 2, and 2 squared is 4. So inside my parentheses now I have a perfect square binomial. But remember that we have to keep everything balanced. So what I add to one side, I have to add to the other side. So the mistake people make is they'll do plus 4 right here. The problem with that is that I didn't really add 4 here. What I really added was 12. And so what I need to add on the other side is I need to add 12. And so when you're doing this and you have to do a factoring, you have to make sure what did you really add to both sides. So make sure you get that. I'm going to have my 3 out here. I'm going to have b plus 2 quantity squared. And then 72 minus 9 plus 12, which comes out to be 75. Okay, now to solve for b, remember we're trying to get the b by itself, so I need to kind of peel off those layers, and the first layer that needs to come off is that 3. So I'm going to divide by 3. Both sides, so I'm going to have b plus 2 quantity squared is equal to 25. And then I'm going to take the square root of both sides. So I'm going to have b plus 2 equals plus or minus 5. And so subtract 2 from both sides, negative 2 plus or minus 5. So remember that that's 2 different questions, or 2 different answers, I guess. So negative 2 plus 5 and negative 2 minus 5. So that's going to be 3 and negative 7. So when you write your solutions, it's going to be b such that b is equal to 3 and negative 7. That means that both of those numbers will work. If you were to go back to your original equation, you could plug in 3 for b, or you could do negative 7 for b, and they're both going to work. In the next unit, we're going to talk a lot more about what those solutions mean and why we want to know about them. But in the meantime, finding the solutions to these equations, that's a very important piece of this. Now, I will tell you that whenever you get integer solutions, which we have right there, it means that you could have factored this. And so if we go back and look at how could you have factored something like this, what you could have done is you could have, in this particular one, you could have just taken out a GCF, and then that would be 24. And then you'd have 3 times, and then what's inside your parentheses, it's going to be 2 or 3 times 8, 6 times 4, 2 times 12. Yeah, 2 times, nope, that's not going to work. Okay, so I'm illustrating something that happens with factoring. Sometimes you try something and then you find out that that's not going to work. So I can't use my 2 times 12 or 1 times 24 or 3 times 8 or 6 times 4. None of those will actually work to give me a 4 in the middle. So actually the way I'm going about to factor it is not going to work. So I go back, if I have to factor this, I have to go back and try something else. Remember that when we solve by factoring, the thing that we make the most use of is that zero product property. And so when I'm going to solve by factoring, one thing that I have to have is I have to have 0 on the one side. So what I'm going to do is I'm going to take that -9 and I'm going to put it on the left. So I'm going to have 3b squared plus 12b, and then -72, and then plus 9 equals 0. So I'm going to have 3b squared plus 12b, and then -63 equals 0. Now, I know that some of you might be thinking, could you have just divided everything by 3 in the first place? Yes, you could have. That would be one way to do it. I could divide everything by 3 right now. So I could do that, but I want to show you something else, and so I'm going to factor the 3 out. So instead of dividing everything by 3, I'm just going to factor the 3 out. And so I'm going to have this. And so to solve this by factoring, I'm going to factor what's inside those parentheses. And so it's going to be 7 times 3, and that's going to be a positive and a negative there. And then using my zero product property, if you remember what that means, it means that either this, or this has to be 0. That's the only way I could get a product of 0. So either 3 has to equal 0, b minus 3 has to equal 0, or b plus 7 has to equal 0. That's never going to happen. So b would be 3, or b would be -7. And those were the two answers we got when we completed the square. And so just kind of depending on, what your numbers are, sometimes factoring is easier and sometimes completing the square is not hard at all. So your answer is going to be the same, but I just wanted to point that out because if you ever complete the square and you get integer solutions, you know that you could have factored it. Sometimes at the beginning of the problem, though, we don't really know if we could factor it or not, and that's the tricky part. So if you can't factor it, you don't really want to waste your time trying to. Okay, we're going to go to the second part of the lesson. So before you start the video for the second part, if you want to go to number 4, 5, and 6 and just try those. In the video, I'm going to start off just doing those examples. There's some different things that you're going to run into there, and so I want you to have already tried them to kind of see like what issues you're running into, and then we'll talk about that.